Hey everybody, it's Zoe. Today I'm going to be talking about limiting reactants and percent yields in Chapter 3. Okay, let's start with a rundown and go through some terms. The limiting reactant is the reactant that is consumed first in a chemical reaction and limits the reaction. The excess reactant is the reactant that is not fully consumed and has excess amounts after the reaction has been completed, so it's basically what's left over. The next three terms will deal with percent yield. The theoretical yield is the maximum amount of product that a chemical reaction can produce. The actual yield is the actual amount of product produced within a chemical reaction. That's because the experiment's not done in a perfect world and not 100% of the product can be made. Our last term is percent yield, and it's the ratio of the actual yield and the theoretical yield multiplied by 100. Now I'm going to go through some steps that will help you solve for limiting reactant problems. The first step is going to be starting with a balanced chemical equation. The next step is going to be to convert the given masses into moles. Next, you're going to calculate the mole-to-mole ratio between the reactants in a specific product. If there's multiple products in the equation, just choose one and stick with it for the rest of the problem. After you multiply the moles of the reactant by the mole-to-mole ratio, you can convert the calculated number into the mass of the product. To do that, you just multiply by the molar mass of the product. Then you are going to repeat steps 2 through 4 with any other reactants in the problem and then move on to step 5. Lastly, you're going to determine which reactant produces the least amount of product. This will be your limiting reactant. This is a visual aid I made, and it kind of acts as a formula to help solve all limiting reactant problems. Pause to screenshot. Now moving on to solving percent yield problems. The first step is to find the theoretical yield, which is the limiting reactant in terms of moles of the product or mass of the product. It doesn't matter whether the values are given in moles or masses, just make sure the units of the theoretical yield and the actual yield are the same. The second step is to identify the actual yield, which is a value that is usually given. Lastly, divide the actual yield by the theoretical yield, then multiply by 100. Again, to make sure this value comes out correct, make sure the theoretical and the actual yield are in the same units. This is another visual aid I made that can act as a formula when solving percent yield problems. Pause to screenshot or copy down in your notes. Let's do some practice. How many grams of silver will be produced from 5 grams of copper and 1 gram of silver nitrate? Pause to work through the problem and get your answer. I got 0.635 grams of silver. So right off the bat, you should be able to recognize that this is a limiting reactant problem, and then you can go through your steps of solving. The first step is to ensure that you have a balanced equation, and I gave it to you already balanced. Step 2 is to convert the grams into moles, and you can see I did that with both copper and silver nitrate. The third step is to convert the moles of the reactant into the moles of the target product. So you can see that I converted the moles of copper into the moles of silver, and also the moles of silver nitrate into the moles of silver. I then identified which reactant would be the limiting reactant, and I chose silver nitrate because it has the smallest amount of moles. I then converted the moles of silver into grams because that's what the question asked for. So now we're going to take the last question a little bit further and find the percent yield. So the question is, what is the percent yield if the actual yield is 0.00 moles of silver? Pause to work through the problem and get your answer. The answer I got was 17%. The first step is to find the theoretical yield, which is the limiting reactant we found in the last problem. Second step, we're just going to identify our actual yield, which is 0.001 moles of silver. From there, you're going to divide the actual by the theoretical yield and then multiply by 100. Again, the answer is 17%. That's all for today's video. I hope it helped, and if you have any questions, please contact the Rinella Learning Center.